Okay, so let's get started on our lesson today. So today we're going to do the same thing as we did on Tuesday. We're just going to take it one more step. How many solutions do we have to this problem? Let's see. Let me go ahead and graph it. So my f of x is going to be let's do this. Square root of x plus 2, which is to the left 2, then over 1 up 1, over 4 up 2. So there's my first graph. And my second graph is going to be my constant line on the other side, negative 2. So what's my solution? There's no solution. Correct? They never cross. There's no intersection. But check this out. I'm going to do it algebraically. I'm going to square both sides, right, because I have a square root. If I square both sides, I get x plus 2 equals 4. So x equals 2. How come if I do it algebraically I get an answer, but if I do it graphically I don't? There's more to it than that. Talk in your table groups. How come you guys have been doing this, right? You should get the same answer graphically and algebraically. They should match. So talk in your table groups. Why isn't that working? I'm going to go ahead and pause it. Ashton, what do you think?
On the graph one, you squared it, and then on the algebraic one, you squared it.
On the algebraic one, I squared it. Kind of screwed things up, right? Because when I square that negative, negative goes away. But why? Two negatives make a positive, you're right, but there's more to it than that. Why? Why does it get messed up? As we say in algebra, I'm doing a legal move, right? If you square both sides, you should get a correct answer. Let's hear it, Amadeus. What do you think? Shouldn't the other side become negative? We don't have to flip any signs, so all we did was square both sides. That's all we did. I just squared both sides. If you do one thing to one side, you should be able to do it to the other. That's the laws of algebra. So why doesn't it work? What do you think? Princess? But why? Why is it no solution? There's our first clue. Grant is correct. Grant says, well, Mrs. Muller, if I substitute 2 back into the original equation, let's substitute 2 back into the original equation. I would get 2 plus 2 equals negative 2, which is, okay, Christian's talking positive, negative, which you guys have been conditioned to do, that this is a plus or minus, right? Still doesn't explain it though, because if I get that, I get plus 2 equals negative 2, and negative 2 equals negative 2. This doesn't equal, right? So it doesn't work. There's a reason why it doesn't work graphically. So yes, Grant, you're correct. If you were to substitute it back in, you're not going to get an equal answer. Therefore, it tells you that it is not a solution to the problem. Okay, but there's a reason why graphically. Matthew, can you just sit up, please? Let me figure it out. Why graphically, there's a reason why the algebra doesn't work. That's exactly why. You guys hear that? Because it's restricted. What would this normally look like? It's the inverse of a parabola. So a parabola would be, the other side of this would be here and here. That's the other side, but that makes it not a function. Remember? That's why we don't graph the other side, because it makes it not a function. But check this out. If it were a function, wouldn't it be intersecting at 2? So what does that tell us? What should you be watching for when you've got equations like that? Sebastian, what should you be watching for? The negative. Because a square root function cannot be equal to a negative, right? Okay, check this out. What about this one? How many solutions does that one have? Let's check it out. So I'm going to split them up, right, so we can investigate them graphically. So I have the square root of x plus 7, so that's over 7, and then over 1 up 1, 2, 3, 4, over 4 up 2. And then I have x plus 5. What kind of function is that? It's a line. It's a linear function. So it starts at 1, 2, 3, 4, 5, and it goes up 1 over 1, or down 1 over 1. So how many solutions, if you look at this graphically, are there going to be? 1 and a fake one. I like it. There is a fake one, isn't there? There's one right here where x equals -3, and as Robert liked to say, there's a fake one, right? There's a fake one right here, correct? There's a fake one. This one is not a solution. But what this tells me is that when I solve this algebraically, I'm going to get 2 solutions, right? Let's check it out. So algebraically, if I were to square both sides, I'm going to get x plus 7 on the left is equal to, okay, I'm going to do this quickly, and then I'm going to come back and I'm going to show you how I did it in my head so quickly. You ready for it? That's a perfect square binomial. X is being squared, 5 is being squared, and I have 5x and another 5x makes 10x. Let me show you how that works. Now, you don't have to do it like I do it. You could actually write it out. X plus 5 times x plus 5. What I'm doing in my head is x times x is x squared. 5 times 5 is 25. And 5x and 5x is 10x. You're always going to have 2 5x's. Make sense? Okay, so that being said, let's scroll down here a little bit. How do I solve quadratic equations? What does this all have to be set to? 0. So when I subtract x from both sides, I get 9x. I still have x squared. And when I subtract 7 from both sides, I get what? 18. Can I factor that? Is that factorable?
Yes.
It surely is. What does it factor to? 6 and 3? So my solutions are, no, -6 and -3. Is that what I got on my graph? I got -3, but I didn't get the -6. talk in your table group. Look at the equation. How could you look at that answer and tell me that it's no solution without graphing? One. Oxal, you want to share? You don't have to. It does. It's because it's touching that invisible, the fake part of the graph. But what if you didn't graph it? How would you know? How can I look at that top equation and say, instantly, -6 is not going to work? Say it louder, Amadeus. What's a negative? So is -3, it works. If you plugged it back in, which is what Matthew is saying, which I think Lays was that's what he was getting at. If I plug in -3 here, -3 plus 5 is still a positive number. So I have a square root equal to a positive number. But if I put a -6 in there, -6 plus 5 is going to make a negative number, right? And square roots can't have negative solutions, right? Square roots are just the positive side of the inverse of the square root. Okay, you guys want to try one?
Yeah. Yes.
So this just explains that we have an extraneous solution. -6 is an extraneous solution. You guys try that one. Okay, many of you are on the right track. Nice work. Okay, let's start with g of x. So g of x, I'll wait for it to be quiet. G of x should be the the square root of x plus 9, which is over 9. Then over 1 up 1, over 1, 2, 3, 4, up 2. H of x is going to be x plus 3, which I know is up 3, and then up 1 over 1. It looks like I have an intersection right here, but I better double check. What's my next perfect square? 1, 1, 4, 2, what's the next one? 9, 3. So yes, that is an intersection there. So x equals 0. That means there's also going to be a fake solution. Where, Robert? Below the first one, right? Somewhere over here, right? Let's see. Here, then over 1, 2, 3, 4, down 2. I bet you there's an extraneous solution right there at 1, 2, 3, 4, 5. X equal to -5 is going to be one of my solutions, I bet, right? Okay. So now I'm going to do it algebraically. Why is the green? Because it's a line. Why is it going horizontal? What do you mean horizontal? Because it's x plus 3. This, right here, is up 3 and up 1 over 1. Y equals mx plus b. Make sense? Y equals 3 is a constant line. Good question. You're probably not the only one that had that question. Okay? So one's a constant line. That's what we've been dealing with so far, right? That's not a constant line. That's actually the equation of a line. So now I'm going to go ahead and solve it algebraically. So I'm going to square both sides. When I square both sides, I'm left with x plus 9 on the left and x squared, positive 9, and 3x and 3x makes 6x. I need to subtract 9 from both sides, and this is where you guys get all trippy, and subtract x from both sides. For some reason, and I don't understand why, As soon as you get a GCF, you guys freak out, right? You should be able to factor out an x. X and x plus 5. X gets factored out and you're left with x plus 5. So my two solutions are x equals 0 and x equals -5. Just like I assumed, x equals -5 was going to be one of my solutions, but it is an extraneous solution, because if I were to put -5 back in here, I would get -2, and a square root cannot be negative. All right. Yay! What about this one? You guys freak out on notation. It's just notation. What does that mean? It's a square root. Okay, I heard Amadeus. He's going to be my token student. I don't like it. If you don't like it, change it. If this makes you feel all warm and fuzzy inside, then do it. Is that better, Amadeus? You feel better? Are they the same thing? Yes.
Yes.
Do you really need to do that extra step?
No.
No. From the very beginning, you could have just said, I'm going to square both sides. Because 1/2 to the second isn't 1/2 to the second just 1? Right?
Right.
It's the same thing. But if it makes you feel better, Amadeus, put it into a square root. Okay? Yes, Victoria.
Why is it like a Friday? Why is it
It's just a different way to write it. Let's think of a different, what's another way of, that we write things two different ways?
There and there.
They mean something different, though. I'm trying to think of something where we write it in two different notations. It's the same thing as writing this. H of x equals x plus 2, and y equals x plus 2. Those two things are the same thing.
1 equals 1 and 1 equals 1.
They both mean the same thing, it's just different notation. And that's the only thing. And to answer your question, Victoria, when we get into our next unit, you're going to want to get real comfortable with looking at it like that. Okay? So it's kind of like a preview into seeing it like that. So something to a 1/2 is half of the root, which is a square root, right? Okay. All right. You guys should be able to graph this, but I'm not going to need you to. What I'm going to do right now is we've got 15 minutes. This is what I'm going to challenge you to do. So instead of me giving you 15 minutes to get started on your practice, first of all, your worksheet has got the front side you guys are going to freak out about as soon as you see it. The front side is the easiest part, but I know you're going to freak out when you see it, so we're not even going to worry about it. We'll worry about it tomorrow, okay? We're going to do the harder side, which is the back side. I'm going to give you 10 minutes. At the end of 10 minutes, I'm going to call up 3 groups, and I'm going to give you a problem that I want you to do that's on that practice. So you better be on task right now, right? Because I will choose a group to come up and do a problem.
From the worksheet you're going to give us?
Well, the whole group is going to go up and have to do it, so you better work together. Okay, so let's set the timer. I'm never going to embarrass you for 10 minutes. No roasting. All right, 10 minutes. Let's get to work.